All right, so in this video, I'm just going to go over the review real quick because I know this is kind of a weird unit. But to start, when you're looking at the initial question, you want to go through, and anywhere you see an x squared, you want to immediately factor it. So we're going to see x squared minus 25. Since that's two terms, 25 we can take the square root of. So we're going to square root the 25, and that's 5 and negative 5, so it's going to be x plus 5, x minus 5. We didn't do anything with the 16, so now that's factored. Oh, sorry for the bell. The domain is, we cannot have 0 in the denominator of a fraction. If you have a fraction and it's like 16 divided by 0, that doesn't exist. It's undefined. That is impossible. So any value of x that gives me 0 in the denominator cannot happen. And the way we're going to choose to write the domain this unit, just to make it a little easier on you, is we're going to say is what is x not allowed to be. And if x is negative 5, the negative 5 goes right here, and negative 5 plus 5 is 0, so that would be bad. X can also not be positive 5, because if we put a positive 5 right here, 5 minus 5 is 0, and that is bad. So, for point discontinuity, this is also called a hole, right? That's if we cancel something out in the numerator and denominator. So if something cancels out in the numerator and denominator, we have created a hole. So if we look at this fraction, I can't simplify anything, so I do not have one of those. Anything that stays in the denominator and does not cross out is the vertical asymptote. So because nothing crossed out, I do not have a point of discontinuity. So the vertical asymptote is just going to be the negative 5 and 5, and it's going to match the domain because I did not cross anything out. Horizontal asymptote are rules that we have to follow. So if we don't remember, the HA rules are we look at degree, and if the top of the fraction and bottom of the fraction so have the same degree, so it's like x squared over x squared or something, if they're the same, we divide. If the numerator is bigger than the denominator, there's none. And if the denominator or the bottom is greater, it's y equals 0. I know that's super abbreviated, but we spent a day and a half on this. So hopefully you remember those or you have them written down somewhere. But we have 16 over x squared minus 25. So the degree of the top is 0 because there's no variables in the numerator. The degree of the bottom is 2 because the highest exponent is x squared. So the horizontal asymptote here is going to be y equals 0 because the bottom of the fraction has a higher degree than the top. For x-intercept, we set the numerator equal to 0. So we say that 16 equals 0. That is, first off, not true. 16 and 0 are not the same thing. And there's nothing to solve for here. There's no x to solve for, so the x-intercept is actually none. The y-intercept is we plug in 0 for x. So we say 16 over 0 squared minus 25. So that's 16 over negative 25. So the y-intercept is 0 over negative 16 over 25. You can convert that to a decimal and make it like negative 0.64 if you want. I don't really care. Either one of those is fine. Okay, to graph it, You can use the TI-84, the calculator, to help if you want, but really we're just going to take all these words on the left and then put them on the graph on the right. So I have a vertical asymptote at -5 and +5. So the vertical asymptote here and here. I have a horizontal asymptote. That was terrible. I have a horizontal asymptote at 0. I do not have a hole that I need to draw, and I do not have an x-intercept that I need to draw, but I do have a y-intercept right here somewhere. You just estimate. And then the graph is going to approach these asymptotes, but never cross them. And they always go in opposite corners. Again, the calculator can help you with a general shape here. This is one of the more complicated ones. It just happens to be number 1. It's going to look something like that. When I grade this on the test, I'm looking at, are your asymptotes in the right spot? Are your intercepts in the right spot? And then does the general shape of the curve match the general shape that it should be? Okay. Second one. I'll go a little quicker here. But the second one, again, anywhere we see x squared, we need to think factoring. This is 2 terms. They're not square rootable, and they both have an x. So if you only have 2 terms, look for a common factor first. If they don't have a common factor, then think about patterns. But this has a common factor. So we're going to factor out a 2x, because they both have a 2 and they both have an x. And when we take that out, we're left with x minus 4. The bottom of the fraction is x minus 4. So we can eliminate x minus 4. Or, sorry, x plus 4. The domain goes back to the original fraction. So if we look at the domain right here, x cannot be -4 because -4 plus 4 is 0, and that's bad. The vertical asymptote is anything that's left in the denominator of the fraction after we simplify. So since we eliminated the entire bottom of the fraction right here, we don't have one of these. The horizontal asymptote are the rules we talked about on the last slide. The degree of the numerator is x squared. The degree of the denominator is just x. So since x squared has 2, x to the first has 1, so the degree of the top of the fraction is greater than the bottom, so it does not have a horizontal asymptote either. The hole, or point of discontinuity, is what we crossed out. So since we crossed out x plus 4, the point of discontinuity is this -4, and then the x value is -4 because we crossed out x plus 4. The y value is you plug in the -4x and see what you get. So we plug in -4 into what's left of the equation, and we find that there's a hole at -4 and -8. The x-intercept is we set the top of the fraction equal to 0 and solve for x, so x equals 0. So my x-intercept is 0, 0. The y-intercept is we plug in 0 for x. So we plug in 0 and we get 0. And since it's the origin, those look the same. So we don't have any asymptotes to draw, but we have the intercept at the origin. We have the hole at -4, -8, and then the graph is just y equals 2x, so it's just a line. All right, next one. This is the last long one, and it'll go faster, but this one's not a fun one. So anywhere you see an x squared, we need to factor. So the denominator is easier, since a is 1 right here. So I need 2 numbers that multiply to 12 and add to 7. So that's going to be x plus 4 and x plus 3. top of the fraction, we need a regular factor because the a is not 1. So 4 times 2 is 8. So it's going to be 2x squared plus 8x plus 1x plus 4. So it's going to be 2x plus 1x plus 4. And then the x plus 4's will go away, and we're going to be left with 2x plus 1 over x plus 3. The domain, again, the domain, we're going to go back to this right here. So if x is -4 or -3, we have a problem because of this factored form right here. Okay? Vertical asymptote is what is in the denominator that we do not cancel out. Okay? So it's anything in the denominator that we do not cancel out. So, because we have x plus 3 left after we simplify, the vertical asymptote is -3. The whole, or point of discontinuity, is what we did cross out. So since we crossed out x plus 4, the x value is at -4. And the y value is we plug in -4 for x. Let's see what we get. So that's, I'm going to run it in my graph a little bit, but that's -8 plus 1, which is -7, over -1. So that's just 7. The horizontal asymptote, so again, the point of discontinuity, I got -4 because I crossed out x plus 4 right here. I got the 7 because I went back to the equation that's left over after we simplify. After you simplify, and I plugged in that x value of -4. And then I just happened to get 7 when I did the math. The horizontal asymptote is back to the rules. So we have x squared over x squared. That's the same degree. So we divide the coefficients. So 2 over 1, 2x squared over 1x squared is 2. The x-intercept, we set the top of the fraction equal to 0. Do the math. So x is -1/2. For the y-intercept, we plug in 0 for x. We replace x with 0. So that's 1/3. Okay. And then the graph itself, we're going to put all this together. So we have a vertical asymptote at -3. So we have a vertical asymptote at -3. Make it a little thicker so maybe you can see it. We have a horizontal asymptote at 2. We have an x-intercept at -1/2. We have a y-intercept at 1/3. And then there's a hole at -4, -4, 7. And then again, you're going to draw curves that approach the asymptote, but do not cross it. Okay, these are much shorter. Remember, we have this equation. The negative is a reflection over the x-axis. The a value is a vertical stretch or vertical compression. The h moves me left or right. The k moves me up and down. So, in this first equation, I have a 3 that does something, a -5, and a +4. So the 3 is a vertical stretch because 3 is bigger than 1. the x minus 5. Remember, h is a liar, so that moves me right 5. And then plus 4 is at the end, not affected by x, so it moves me up or down the k value, and plus 4 moves me up 4. In the second one, we have a negative sign, a plus 2, and a minus 6, so we're going to have 3 transformations again. The negative sign is a reflection over the x-axis. The plus 2 moves me left 2, and the minus 6 moves me down 6. So on the transformations, you're just using this equation that we've had forever, and just stating the transformations in English, what is occurring. This is also transformations, so this is the same equation as the last two, but you're going to write the equation instead of me giving you the equation. So we want to reflect, left, and down. So we're going to do 3 things. So to reflect, you put a negative on it. To go left, that's the bottom of the fraction. And to go left 2, we're going to do plus 2. And then to go down 1, we're going to do minus 1. Okay? This second one, we're going to go left 1, down 2, stretch it by 3. So again, we're going to have 3 things we're going to do to it. So if we want to go left 1, we're going to put plus 1 in the denominator. If we want to go down 2, we're going to put minus 2 right here. And if we want to stretch it by a factor of 3, that's the a value. So if we stretch it by a factor of 3, a 3 just goes up top. Generally, these are going to be called g of x. But I'm not going to count off for that. So there's transformations. So the a is vertical stretch or compression, the negative is a reflection, the h is left or right, and the k is up or down. Okay, these are similar to the first 3 questions that we did, but instead of all the stuff, you're only going to talk about asymptotes. This is kind of setting you up for the multiple choice part of the test. But the work stays the same. So we have 3x squared plus 10x plus 3 over x squared minus 4. So everywhere you see an x squared, you want to factor. So if you factor the top, it's going to be 3x plus 1, x plus 3. Y'all can just regular factor that. I don't expect you to do that in your head. I just don't want to show the work. And then the bottom is going to be x plus 2, x minus 2. Then we need to see if anything cancels, which it doesn't. So instead of like types, number, and what are they, just think of, does it have a vertical asymptote or not? Does it have a horizontal asymptote or not? So the VA is 2 and negative 2. Because these do not cancel out in the denominator. The horizontal asymptote, you're looking at the degree. Since it's x squared and x squared, those are equal. So the horizontal asymptote is going to be 3x squared over 1x squared, which is just y equals 3. So the types, we have a vertical and a horizontal, which is both, because we're not talking about a slant asymptote yet. The number is like how many are there. There's 3 total. We have a vertical at x equals 2 and negative 2, and we have a horizontal at y equals 3. So these are just kind of a weird way to ask the other the first things. They're just saying what are the vertical and horizontal asymptotes. I don't know why I stumbled so hard to get that out, but so this one, we don't have to factor this, thank goodness. So nothing cancels. Remember, these are protected in parentheses, so those x's cannot get crossed out. So there's nothing to cross out here. So we have a vertical and a horizontal. or you can put the word both, I don't care. The horizontal asymptote is you have x and x, so that's 1x divided by 1x, so it's a y equals 1. The vertical asymptote is what makes the denominator 0, so that's going to be x equals 5, so there's 2 total. Last one, we factor the top, so that's x minus 6, x plus 2, over x plus 2. The x plus 2's are going to cancel. So the vertical asymptote and the horizontal asymptote, okay? The vertical asymptote is anything that's left in the denominator after we simplify. So since the denominator was canceled out, I don't have one of these because there's nothing left in the denominator after we simplify. The horizontal asymptote, you're looking at the degree. So we have x squared over x. The numerator of the fraction is bigger. If the top is bigger, we have none. So we have 0, and we don't have either of them. None or neither, I don't really care what your phrasing is, but we don't have one. Okay? So again, vertical asymptote is what does not cancel when you're simplifying in the denominator. Only in the denominator is the vertical asymptote. The horizontal asymptote are those rules that we hopefully have memorized by test day. Please. Last but not least, again, setting you up for a multiple choice type scenario. How do you determine if there's a point discontinuity or hole in a graph? So the only way a hole occurs in the graph is if a factor cancels in the numerator and denominator. So for example, we have like x plus 2, x minus 5 over 2x plus 1, x plus 2. The x plus 2 is canceled, so there'd be a hole at x equals negative 2. Okay, there'd be a y value, but we don't have to be crazy here. So if a factor cancels out in the numerator and denominator, you have created a hole or a point of discontinuity.